So Cherish said divide. Very good. And she further said x is equal to 3. All right. So now let's give the properties that we use for each step. When Javier suggested we simplify the numbers, um, I moved the negative 3x to the left side so we can combine the numbers with the same variables. But to eliminate the negative 3x, we added it to the right side. So that's our clue. We added something. So that means the property we use for that is addition property of equality. Okay? Click enter so you can go to the next line. We combine the like terms 2x and 3x. So if you're only combining like terms, that's CLT, combine like terms. Sometimes we also put simplify. Okay? So maybe you're wondering, okay, Ms. Arciaga, what's the difference between a property and a simplify only? So if you're doing something on both sides of the equation, like you added 3x to the right and to the left, that's a property. But if you're only, combining like terms and what do you call this? Maybe combining two numbers or coefficients like 2 and 3 are the numbers, right? You combine them on the left hand side only, but you don't do anything with the right hand side, then you just put simplify. And according to Cherish, she divided both sides by 5. So when she did that, she divided the left by 5 and she divided the right by 5. So if you do something on both sides, then that's a property. So division, property of equality. All right. Okay, I'll give you 10 seconds wait time to ask questions if you have any. If you got no questions, either click on the thumbs up sign or you can type got it in the chat just to kind of give us some feedback. But if there's something that you got confused in, let me know so I can go over it before I move on to the next example. Okay, no questions? No feedback either? Ooh, that's not good. All right, did you get it? If you did, click on the thumbs up sign or you can type, a short feedback in the chat. Say something like I got it or a simple, you know, um, I understood it or yes or no will do. Any comments? Any questions? I got it. Thank you, Ricanel, for giving me that feedback. What about the others? Any comments? Any questions?
Got it.
Got it. I appreciate that. Thank you. Okay, if you guys have any question, just let me know in the chat. Okay. Maybe you will remember your question once we see the next example, right? Okay. So now let's move on to the next one. Our goal in the second example is to solve an equation with grouping symbols. Solve an equation with grouping symbols. Okay, so on the left-hand side, I think it was Luis, right? Okay, Luis, let me get back to you. So you said earlier in the chat that you got 12x minus 16 on the right-hand side. Um, you mind explaining, Luis, how you got that?
Oh, I mean 9 times x minus.
Uh-huh. Let me just type right here.
So 3 times 3x equals 9x.
Uh-huh.
Minus negative 4 equals negative
Huh? Keep going.
Divided by 1/4 quarter times 32 equals 8 and 1 times 56. I haven't figured it out yet.
Mm-hmm.
Well,
Mm-hmm. 56 divided by 4. Sounds like somebody wants to do math as well, right, Louise? Okay, so 56 divided by 4 is? Anybody can tell us what 56 divided by 4 is? You can type in the chat if you got that in your calculators.
14.
14. All right. Ooh, that's a good question. Um, Amira asks, how do we get the 8? How do we get the 8? Oh, okay. Luis, are you here with us? Still with us?
Yes.
Okay, can you explain one more time how you got the 8?
Um, so since this is a 1/4 quarter, I basically divide 23.
Did you mean 32?
Yeah, I mean, yeah, 32.
Okay,
I don't know. I sometimes get confused because I do it like that.
nice. And that's a skill that you have to nurture, you know? So, Amira, if I may rephrase what Luis mentioned, since he saw that there's a 1/4 at the beginning of the parentheses, he divided 32 by 4. So, um, pretty much when you multiply fractions, let me see if I can write here on the left hand side. Okay, so I'm going to explain it over here. So pretty much if you see like 1/4 and then a 32, by default the 32 has a 1 underneath it, right? So you will multiply the top and the bottom. Okay, so the top will become 32, and then 4 times 1 at the bottom will become 4. So that's how Louise got 8. All right, did that answer your question, Amira? Okay, so going back over here, no worries, honey. So anybody who would like to continue from where Louise left off? So after these, what do we do? Let me just clear the ink. Anyone? Still thinking about it? I'll give you some 10-second wait time. What are we going to do with those that have variables in them?
Don't you add them together?
Silly said add them together. Okay. Silly, let's think about it one more time. Can I add them if one is on the right and the other is on the left? Or do we have to move one of them? No? So what should we do first? Let's choose which one you want to move, honey. Do you want to move the 9x or the 8x?
The 9x.
Okay, let's do that. Um, I'm going to keep the negative 12. And then you said move the 9x, but since 8x was there first, I'm going to write it first. Now, what will happen to the sign of 9x, silly? Will it become positive or negative?
Positive.
Okay, let's think about that one more time. It was originally
Negative.
negative. Okay. All right. And then the 14, we'll keep it there. Okay, so I'll bring down negative 12. Billy, help me with this. What is 8x minus 9x?
1.
1. Will it be positive or negative though?
Positive.
Okay, remember, we take the sign of the bigger
No.
number.
Negative.
Negative. So it's going to be negative 1x. I'm just going to write it as negative x, okay? And then let's bring down the 14. Awesome. Now, silly, which number should we move next?
Move minus the 14, and then we'll add the 14 to the negative 12.
Okay, so we minus the 14 on both sides. And then, okay, and then you said we add the 14 and the 12 together. But what will be the final sign here if I add them together? Is it negative or positive? If they're both negatives, okay. If they're both negatives, you have to add the values, but you keep the same sign. Mm-hmm. So it
So
will
three and
become
negative
negative.
compound.
Oh, we're not multiplying though, honey. So if they have, yeah, if you have the same sign, we keep the same sign. So negative what? Negative.
What
What's
x?
okay? 12 and 14 together become.
And negative 2.
Oh, hang on, honey. So pretty much we have. Oh, let me write over here. You have a negative 12 and a negative 14. If they have the same sign, then their final answer has to have the same sign as well. Okay, and then since they have the same sign, you have to add the values. So don't get the difference. So how will we add them together? Let's do that again. So let's add 12 and 14 together. And what should we get? Jaden said 26. Do we agree with Jaden?
Yeah.
Yep. Okay. So let's do that. So negative 26, okay, is equal to negative x. Okay, thank you, Silly, for helping me with that. And Jaden, thank you for helping us getting the combination of those two numbers. So now our next problem is, well, we can't have a negative on the x. So what are we going to do? Jaden, would you like to continue? What are we going to do? What will be our final answer? The x has a negative, the 26 has a negative. So what are we going to do with that negative sign, or the negative 1? Negative 1x. So what are we? Swap it around. Cool. Okay, so when you move the x, which is negative, to the other side, Amira, you're right, it will become positive. And when you move the negative 26 to the other side, it will become positive. So it's equal to 26. That's great. So always write down your answers in standard form. And by standard form, let me put an asterisk on that. So standard form means the variable is on the left hand side. So variable on the left. All right. Okay, so let's review what we just did. We're given this problem right here. Um, okay, you can go ahead and revise that on your notebook. Okay. All right, so we're given this problem here, the one with the fractions originally, and our goal was to solve an equation with grouping symbols or with the parentheses. Okay, so Louisa started this by distributing, right? So we put distributive property, and then Silly decided to move the 9x to the other side, so she subtracted 9x, right? So subtraction property of equality. Now, can this be done in another way? So what if we decide not to subtract 9x? Can we think of another way to combine like terms? While you're thinking about that, I'm going to continue writing down the properties, but maybe in the chat, let us know if you get an idea. Instead of using subtraction property, like in what other ways can we solve the same problem? Simplify the 8x and the negative 9x. And then Silly decided to move the 14, and that's another subtraction property of equality. Then Jaden helped us simplify the negative 12 and the negative 14. And last but not the least, Amira said, swap them around so it will look like the standard form. So when you switch these two around, you added x to the left and you added 26 to the right. Or you can also say, you can multiply both sides by negative 1, right? If you multiply both sides by negative 1, that will also become negative. So whichever you're more comfortable with, you could do that. So we could use addition, property of equality, but I'm also going to say you can also use multiplication. If you multiply by -1, okay, and if you can multiply by -1, you can simply divide by -1 as well. So all those three properties may work for the last one. Okay, so going back to my question, did anybody come up with another way of solving this? Instead of subtracting 9x from the right hand side, is there another way to do it? What if you wanted to keep the 9x there and move the 8x instead? You think that's possible? Can you type like yes or no in the chat if you think that's possible? Yes? Okay. So you can also keep the 9x and move the 8x. In fact, some students prefer to keep the bigger number, you know, um, keep it on the side. Oh, go ahead.
How did we get negative 9x?
How do we get negative 9x?
Wait, no. Because stand the number 26 negative was 20, it was straight away positive 26.
Okay.
But that's also because I do math every day.
That's what I was asking for actually early. I said, is there another way to do it? Because I know for sure that some of you, just like what you mentioned, Louise, your answer was positive, like right away, correct? Okay, so let me answer your first question. Where did the negative 9x come from? In Silly's method, she kept the 8x on the right and moved the 9x over. So when the 9x, which was originally positive, was moved to the right, it became negative. However, if your method is different, let's say, for example, you kept the 9x there. Maybe I should write that down over here on the left hand side. So if you kept the 9x there, you will move the 8x over. Does that make sense? And you will have 14 plus 12 if you're moving the 12 to the right. So if you're moving the 8x, then this will become positive right away. And then this will become 26. Is that how you got it, Louise? Okay, so I'm assuming that's how you got it when you said it's straight positive, right, Louise?
Wait, what was that again?
Okay, so the way I got it is when you said your answer was positive right away, you move the 8x instead of the 9x. Did I guess right?
Yes.
Yeah? Okay, so my point in showing you that is whichever method you follow, or you guys can come up with another method, aside from the two that you see on your screen. Um, what's the most important part is that you follow the properties correctly and you combine the numbers correctly. Um, but either way, you'll end up with the same answer. Okay? All right. So let me erase this. In the first two examples that we saw, um, each of these two equations has one solution. Okay, so can we type that one for emphasis? So each equation only has one solution. The first one has, um, okay, I run out of space over here, but it will be at the very bottom. Okay, so the first one has 3 as a solution, while the second one has 26 as a solution. But if you move to the right hand side of your screen, okay, equations do not always have one solution. In fact, some of them could have infinitely many solutions. Okay, so right here I highlighted that for you. Infinitely many. What does that mean? What does infinitely many solutions mean? Can somebody type that in the chat? What does infinitely many solution mean? When you get an idea, type it in the chat. Could be any solution. All right. Okay, so when you said could be any solution, pretty much it means the same thing as whatever number you substitute in the equation, it will always work. Like it will always make the equation work. Very good, Annalise. That's a very good idea. So the solution could be any real number. Mm-hmm. All right. Well, let's show them some examples of that. Give me one sec. Let me just pull up something from my drive. I think when I went over this with my period one, I deleted the original problem. So that's why the problem disappeared. Give me one sec. I'm gonna pull up the original problem in my drive. Okay, so Annalise said that the answer could be any solution if it's infinitely many. So whatever problem you substitute or whatever value you substitute for the variable, it will make the equation true. Well, how about the other possibility that I highlighted there? It says no solution. So what does no solution mean? What does it mean for an equation to have no solution? Go ahead and type in the chat while I'm pulling something up from my drive. Sorry for the wait. My internet is loading slowly. And while waiting, let me just remind you that I will be sending you a link very soon, so you guys can share with me your digital notebook. So remember, I told you that we will be including your notebook in the grading. So if you have that combined, all the slides I've been sending you, you have this week to do that, and we will be grading them this week as well. Okay, so Annalise mentioned earlier that infinitely many solution means plug in any number and it would work, right? Well, let's see. This is the given information. How do we see it algebraically? Okay, so if I could borrow Luis's idea earlier, when he distributed the 1/4 to the grouping symbol, we could also do that here, right? There's a 3, and then there's a grouping symbol. So if we multiply that and distribute, can somebody write in the chat what's that going to be equal to? If you distribute the 3 to the 5x plus 2, what will be the result? (15x plus 6 according to NSE. So 3 times 5 is 15x, and then 3 times 2 is 6. Good job, honey. Okay, equals, I'm just going to copy the 15x right there. All right, so NEC use distributive property. Click on enter so you can write in the next line. Go back, then enter again. All right, so what could we do here? You have 15x on both sides. Combine. Cool. All right. So either way, we have to move one of the 15s, correct? So let's say I keep that 15 on the left and move this one, okay, here. It will become, what's the new sign of 15? Of the other 15 from the right if I move it to the left. Since it's originally positive, Amira said negative 15x. Okay, equals. What can we do with the 6, Amira? If I move it to the right, what will be its new sign? Yep, negative 6. Cool. All right, now what will happen to 15x minus 15x? Do we have anything left? It's like 15 apples minus 15 apples. 0. Very good, Edgar. So some students write 0x. That's also correct, but 0 times anything will just be 0. So just clean it up a little bit and just put 0. Oh, now we have a problem. 0 equals negative 6. Is that even possible? So is that true or false? What do you guys think? Is 0 equal? Very good, Edgar. So this is a false statement. All right. So if we come up, oh, I spelled it wrong. I'm a math teacher. I'm not good in English. Okay, so this is a false statement. Um, it means that whatever value we plug in for x, you know, it will result to a false statement. It will not work. So what do you think? Um, so how many solutions do you think this equation has? Is it the one that has infinitely many solutions, or is it the one with no solution? What do you guys think? No solution, according to Cherish and Amira. Okay, so I'm gonna write that here on the other side. Let me just finish this. So Amira said she combined like terms, so she subtracted 15x from both sides, and then she simplified. So this equation has no solution. Okay, so algebraically, that's how an equation with no solution looks like. The left hand side does not match the right hand side. Very good, Edgar. No solution. Cool. So you can verify if you plug in 1 here. I'm gonna write here on the margins. Let me see. Okay, so the original equation, I'm just gonna write here randomly. You don't have to copy this down. If I have 3, 5x plus 2 equals 15x, and I try to use 1, oh, sorry, I'm just guessing where the pen is. So if I substitute 1 for x, I get 5 times 1 is 5 plus 2, that's 7, right? Okay, now I don't see my 7. Where did it go? Um, okay. There, that should be positive. Uh, again. Okay. So if I substitute 1 for x, don't copy this. I'm just trying to figure out very soon, honey. So 5 plus 2 is equal to 15 times 1. 5 times 1 is 5 plus 2, that's 7. And this becomes 15. And again, this is false, right? So whatever number you plug in, it will be false. We have last one, silly, and then you'll have time to do your independent work. Okay, so for the last one, let's see what happens. Um, if you distribute the negative 2 to 4y plus 1, okay, what do we get? You get negative 8y. Remember, negative times positive is negative. Okay, then negative again, because that's a negative 2 and a positive 1. So you get negative 2 when you multiply 2 times 1 is equal to, oh, what happened here? We wrote the same thing twice. So this is the given, right? Oops. So that's the given. And then we use distributive property. Okay, we ended up with the same result. So what conclusion can we make? Or maybe you don't know what conclusion to make yet. So what if, well, you still see variables on both sides, Mr. Arciaga. Don't you combine them? What do you guys think? Can we combine them? Can we combine the 8y's together? I'll start writing the first 8y on the left-hand side. And Louise said negative 8 plus negative 8. Yeah, so when you move the other negative 8, Louise, what will happen to its sign? Would its sign change? The negative 8, should I change it to positive or keep it negative?
Keep it negative because if it's positive, then it will be 0.
And
It will be 1 on one side and it will be 2 on the other side.
okay,
It will be negative 5. So make would be basically a false statement. But if you add them, then it would be a different answer.
okay, but remember, we don't we when we take out a variable or an expression from one side, we do its reverse operation. So if this was originally negative, right, I have to add 8y to both sides. In other words, if I move it I have to make it positive. But I get what you mean. It will not work, but that's okay. We saw an example already in which it didn't work, and we concluded that it has no solution. So, well, let's see. Let's just follow the properties, which is do the reverse operation, and let's see what we get. Okay. So if I have negative 8y, okay, so we're going to move that here and make it positive, and you were right, it will become a 0. But let's see what happens if you get a 0 on the left. Um, Before we continue, oh, sorry, my little one is here. She's done with her Zoom. Okay, you have a negative 2. Okay, honey, you want to watch on the YouTube now? Okay, go to the living room. Mommy's working. All right, so you have a negative 2 over here, and then you have another negative 2 from the left hand side. So what will you do with the other negative 2? So if you move this one over, just like what we did with the negative 8, you're going to reverse its sign as well. So plus 2. And Luis, you were right. You're going to end up with zeros. But the nice thing about here is the left hand side is 0, and the right hand side will also be 0. Okay? But my question was, going back to what you mentioned earlier, is it still a false statement, just like the first example, or not anymore? What do you guys think about this one? It's true, according to Edgar. So this is a true statement. So if a false statement has no solution, okay, what about um, the example that we just did right now? And let me write down the property here. We added to both sides, so that's addition property of equality. Okay, honey. All right, and then we simplify. So if earlier we made the conclusion that it has no solution, if it's true, what does that mean? This equation has
A solution.
how many? Is it one solution or infinite many? Infinitely many, according to Edgar. Okay, has infinitely many solutions. All right. Okay. So, all right. So we saw two equations that are different. Um, were different and similar at the same time. They're similar because we didn't get one solution, right? Like we did over here. Um, but they're different because one has no solution while the other has infinitely many solutions. In fact, you can also say this equation is an identity. Identity. Okay, it's an identity because the left and the right hand sides match. All right. Okay. Oh, I went 4 minutes over time today. Um, Let me go back to your Schoology so I can show you what you're gonna do next. Hang on, I have to stop my